This video is about doing dilutions. Now there's two different ways you could do a dilution, and the first way I'm going to show you to work for it is probably what most people would do on the quiz or the test or whatever, and then I'll show you another way of why that little shortcut works. So when you look at this, it says if you have 455 milliliters of a 6.0 molar nitric acid used to make a 2.5 liter dilution, what is the molarity of the dilution? So the shortcut that a lot of people will use, and it works well and it's nice and easy, is M1 V1 equals M2 V2, where the M1 and the V1 are from the stock solution. That is the more concentrated one, and the 2's, the M2 and the V2, are from the diluted solution. So if we're going to do this, what we could do is label the stuff in the problem. So V1 is at 455 milliliters, M1 is a 6.0 molar. That is the more concentrated solution. So this is what we're diluting it to, 2.5 liters, and it's asking for the molarity of that dilution. So we could really just plug these numbers in. What we start off with is the 6.0 molar as M1. V1 is 455 milliliters, but I'm going to convert that one to liters because we need the units to be the same, milliliters and liters. M2 is what we're looking for, and the other volume is 2.5 liters. And again, this is why we need the same units for volume. So mathematically, what you do is you multiply 6.0 multiplied by 0.455. You get an answer there, and then you would just divide by this 2.55. So M2 equals 1.1 molar. Now it's nitric acid. Since it doesn't say hydro, we know that it is not binary. We're going to need a polyatomic ion in there no matter what. The acids for us begin with hydrogen. So now you look at the IC. That tells you you're going to go to the polyatomic ion that is nitrate. So you have H, that's a positive 1, nitrate, that's a -1, so you get HNO3. And then that ends up being your answer. Now that is the short way in doing it. And like I said, that works out nice and neat. If you wanted to know why it works out like that, what you would do in a problem like this is, you know you have 6 molar solution and 455 milliliters of it. So I'm going to write out the 6 molar, but I'm going to write it as moles per liter. I'm going to multiply it by that volume, making it into liters. So the liters will cancel out. What that's telling you is that there are 2.73 moles of HNO3 in that stock solution. So now, remember, molarity is moles divided by volume. So for the dilution, what happens is you have that 2.73 moles of nitric acid. You're adding enough water to bring it up to 2.5 liters. So that ends up being the new volume. So now you divide that by that new volume, 2.5 liters, and that gives you 1.1 molar, which again is the exact same answer we got before. It's a little more work this way, which is why people usually just go with the other method, but either one works fine. And that's how you do dilutions.